All right, algebra. In this video lesson, we're going to talk about solving two-step equations. Why do you think they're called two-step equations? That's right, you can do it in two steps. Before we do that, though, I want to take a look at one-step equations, which we've been doing for quite a while, and make sure everybody is comfortable with some of the concepts I'm going to talk about. So let me zoom in here, and let's just talk about these one at a time. So to solve x plus 5 equals 9, we've got to think, okay, what number can be added to 5 and produce a 9? And you can solve this in your head without doing any work. I totally get that. But I want to make sure you understand the work that I'm going to show you, because that's going to play out much simpler in the two-step equations if you can do that. So what we learned is that addition and subtraction patterns will cancel each other out, right? Because addition and subtraction are inverse operations. That is to say, adding and subtracting the same number will effectively cancel out. What we learned in terms of an equation is that the equal sign is kind of like the dividing or the divider between a balance scale. So if I were to take 5 pounds away from the left side of the scale, in order to maintain the balance, which is what the equal sign means, I would have to make sure I took 5 pounds away from the left side of the scale, right? So consider, why did I have to do it to both sides? To maintain equality. Why does it work? Because 5 subtract 5 cancels out, and we effectively get 0. X plus 0 is just x. Now, we know it's still equal because we applied it to both sides, and now we can do a simple subtraction. 9 minus 5 is 4. So the answer to my problem is 4. Now we can go back and check it. 4 plus 5, is that 9? Sure it is. Okay, the second one, y minus 1 equals negative 4. Now, this is not really any different. You notice I want to know what the value of y is. We're working with negatives, so that's why it's really important that you don't get caught up thinking, wait a minute, negatives. Do I go backwards, forwards, left, right? What does that mean? Remember what we did over here. Look at the variable. We want to get it alone or isolated. That's what's going to tell us its value. We can apply an operation to both sides and we'll maintain equality. So the balance will still be remaining. We have to think, well, how can I get rid of subtracting 1? Right? That's what's keeping me from having y by itself. So I'm going to think I need to add 1 to both sides. I've got to maintain equality, so I did it to both sides. The y is now isolated. And negative 4 plus 1 is negative 3. Right? When you add a number, you move to the right on the number line. When you subtract a number, you can move to the left. You just got to be careful with subtracting negatives, adding negatives. So we'll get there. So think about the next one-step equation. 12z equals 6. Well, what is the 12 doing to the z? What operation is present? Multiplication. The pattern your book stated is that division and multiplication are inverse operations. So we know that we can get z by itself, which I want you to think there's really a 1 here. 1z is just z. So how can I turn that into a 1? Well, I could subtract 11, but does that mean that the 12 times z will go away? No, we have to think 12 times z can only be canceled if we divide by 12. Now, if I did it on one side, I've got to do it on the other side. Why does that work? Well, 12 divided by 12 is 1, or 1z. 6 divided by 12 gives me my answer of a half. So, addition and subtraction cancel each other. Same here. Division and multiplication will cancel each other. So one more before we move on to the two-steppers. A divided by 3 equals 13. We're going to get that. There we go. A divided by 3 is 13. So currently I have A being divided by 3. If I want to know what A is by itself, I've got to get rid of division by 3. Division will be canceled if we multiply by 3. And we've learned that's really a reciprocal. You could say 3 over 1 if you wanted. But I put 3 on the top here to show multiplication, but I've got to do it over here as well. So 3 divided by 3 cancels, and I get 1A, again, which is just A. You could say that there's an understood 1 there, but it's much simpler to now understand that it's just A, and then 13 times 3 is 39, or my answer. Now that's all well and good if we understand that we can use inverse operations to cancel. We're still going to use inverse operations to cancel, but first I want to bring something to your attention. So let's suppose we were asked to evaluate the following expression. 2 times x plus 3 equals 27. And evaluate, of course, remember that means to plug in that value. So if x equals 12, what am I going to do? I'm going to say 2 times 12, I'm going to replace it, plus 3 equals 27. Now, order of operations, or PEMDAS or PEDMAS or whatever you guys write, it says we've got to do parentheses first. There's nothing inside the parentheses. We've got to do exponents next. There's no exponents. We've got to do multiplication and division next. Left to right, that is, right? We'll work it left to right. Now, that is present here. So we've got to multiply these before we add the 3. Remember, addition and subtraction come last. So we're going to do that. 2 times 12. So I'm going to multiply. I'm going to get 24 plus 3 equals 27. Well, I didn't really do anything there because 24 plus 3, yeah, that's 27. 27 equals 27. Oh, now I know that I did it correctly. But what I wanted you to pay attention to was the order we did that in. We did multiplication first. Then we did addition. Right? And I could have left this, open-ended. But I wanted us to make sure we checked it and we did it correctly. So now we're going to go back through that equation as if we didn't have an x value to plug in. Okay, we're basically testing that x value. So what I want you to consider is, do we do multiplication first here? 2 times x. Well, I don't know what x is, if you kind of pretend like you don't know what happened 1 minute ago. And then you add 3 to whatever that is, and the total is 27. So, yeah, how do we do this? I mean, you guys can probably get it. Many of you are really quick with guess and check. You've got great number sense. But here's what I want to point out. If the order of operations for evaluating was PEMDAS, well, what's going to happen when we solve equations is it's going to be opposite. It's going to be backwards. So to solve, we're going to do PEMDAS backwards. I'm going to write it because I don't think SADMEP, I guess is what it would be. We're going to do that. We're going to go right to left. And if this bothers you, you guys can just remember the simple steps I'm going to show you here in just a second. But this is effectively what's happening. So instead of doing parentheses, exponents, multiplication, division, addition, subtraction, I'm going to do addition and subtraction first. Now, what happens? I need to get x by itself after it focuses. In order to do that, I've got to get rid of the times by 2 and the addition of 3. But if you pay attention to what this means, let's take care of the 3 first, because that's addition. How would I get rid of a plus 3? I'm going to do a minus 3. To maintain equality, because I've got to do it, I've got to make sure it's still equal, I've got to do it on this side, right? You take 3 cookies away from your brother, you got to do it from your sister as well. So, why did we do subtract 3? We get that cancellation. This is a pretty simple problem. 27 minus 3, that's 24. And I haven't touched 2x. It's still over there. So I still have 2x equals 24. Now what do you notice? Well, I'm really close to getting x by itself. All I've got to do is get rid of the times by 2. How can we cancel out a multiplication by 2? We can do a division by 2. Not on one side, but on both sides to maintain that equality, right? That's the fair treatment. So divided by 2, we get x equals 12. Oh yeah, we knew that already. But hopefully I made my point that when you solve a two-step equation, you can actually do the order of operations backwards. Now there are exceptions to this. I'm actually going to work that problem a totally different way, and I'm going to show you why this way is a little bit easier. So we have 2x plus 3 equals 27. What if someone said, no, you need to divide first, right? It's closer to the x. We need to take care of that first. Well, let's make sure we understand what that actually means. You can't just divide this by 2 because you haven't treated all terms on the same side fairly. So what you would have to do is divide the entire left side of the equation by 2 and the entire right side of the equation by 2. Now, it's all well and good. What we're going to do, we're going to get 2x over 2 plus 3 over 2 equals, we can call that 13.5 if you want. And you see why they divided by 2, it canceled out. But then you're left with this problem. X plus 3 halves equals 27 halves. You got to do all the fractions and all that sort of thing. Now, is this going to give us the right answer? Of course it is, because we'll subtract 3 halves and we'll get x equals 24 halves or 12. But with a lot more tediousness, a lot more complicated math. Not super complicated, but compared to what we did, more complicated. So I hope the previous example made a little bit more sense, because this is all we've got to do to solve a two-step equation. We're going to get rid of the constant, which is the number that's added or subtracted. Then we're going to get rid of the coefficient. So we can call this a constant. Again, it's just a number by itself. And then a coefficient is a number that is attached to a variable by either multiplication or division. So we're going to do the constant first, then we'll get rid of the coefficient. That means you're going to add or subtract first, then we're going to multiply or divide first. Let's see how that plays out in these examples. So we have y over 4 plus 11 equals 10. We have the constant of 11 and the coefficient over here. Wait a minute. The coefficient is essentially going to be multiplying the variable. So what I'm going to do, there's an understood number beside this y. It's a 1. 1y is y. So y divided by 4 is the same thing as 1/4 y, right? Plus 11 equals 10. So what I've got to make sure I remember is that I want to take care of the constant first, and then I'll get rid of the coefficient second. That is going to be the simplest pattern. Yes, there are other ways to do it, but this is the simplest. So how do I get rid of the constant plus 11? I've got to subtract 11. So it cancels out, and I'm going to get 1/4 y equals -1. Now we remember our work on fractions. How can we get rid of a fraction? Well, we could say a couple things. We could say the 1/4 is multiplying by the y. So some of you in class have said, hey, let's divide by 1/4. And some of you have latched on to the idea that, hey, I can use the reciprocal. Dividing by 4 is what this was originally stating, and it's still saying that, but in a different way. So I can actually multiply through by the reciprocal of 1/4, which is 4 over 1. I've got to do it on both sides. So I'll get y by itself. Y. Because 4 over 1 times 1 over 4, we get the cancellation. And then -1 times 4 is -4. Now, you see a little option over here to check. Let's check our answer. So we've got -4 divided by 4 plus 11 equals 10. So all I did was plug in the value I got for y to see. So what is -4 divided by 4? That's -1 plus 11. Is that 10? 10 equals 10. Yes, it is. All right, so take a look at this one. Pause the video and try it yourself. Okay, so if we understood what I wrote earlier, then we want to take care of the constant first, and then we'll get rid of the coefficient second. So how do we get rid of a -9? How do we deal with it? How do we get rid of it so that we can get z by itself eventually down here? We're going to add 9. We're going to do it to both sides to maintain equality. So I've got 3 times z equals 51. And then I've got to get rid of the 3 times z. I've got to get z by itself, so I'll get rid of the times 3 by division. And we'll get an answer of 17. Okay, what happens when we mix fractions in? Nothing. It's exactly the same. We can still treat 1/3 as a constant. So what we'll do, we'll subtract 1/3 because it was adding. I will do that from both sides, but I got to do a little fraction work here. So 6 can be written as 18/3. See what I did there? 18/3 minus 1/3 is 17/3. Now what do we have? We have a fraction set equal to a fraction. So you can do one of two things. You can understand that it's a proportion and cross multiply. Or you can just think, well, x is being divided by 2. If I multiply by 2 on both sides, I will be finished. So we're going to do that. You're going to get the same answer either way. X is now by itself, 17 times 2. Remember, when you multiply a fraction by a whole number, you only do the top times the top, bottom times the bottom. What bottom? Is a 1. 34/3. That does not reduce. Now we're not going to check that one for the sake of time. I don't want this video to go over 15 minutes, so I've got 2 more. Very similar. Very similar, but are they going to have the same answer? Or are there different equations? It's possible, but different operations probably indicate no. So think about this one, right? In all the previous problems, I've had the variable part first and then the constant. Well, let me change the order around because you see, when you add, the order actually doesn't matter. So what a lot of people will do mistakenly is they'll look here and they'll think, oh, it's plus, so you're going to subtract. Well, coincidentally, that works for this problem. But pay attention on the next one and let's see what happens. So if we subtract 10, 10 minus 10, yes, that does cancel, but I've got to do it on both sides. So what is it that canceled? The 10s. This 2z is being added, therefore we treat it as positive. And then 8 minus 10 is negative 2. What operation do I need to get z isolated and therefore find its value? Get rid of the times 2 using division by 2. So I'll have z equals negative 1. Fantastic. Let's think about it. Z as negative 1. 2 times negative 1, that's 10 plus negative 2, 8. Sure, it checks out. But what happens over here? 10 subtract 2z equals 8. So what I want to think about is, how do I get z along? Well, the 10 is subtracting 2z, but the 10 is itself positive. So you don't look at this to tell what to do with the constant. You look at what comes in front of it. Whatever sign is out in front tells you what type of 10 that is. And it is a positive 10. How do I know? Because it doesn't have a negative. So in order to get rid of a positive 10, I'm going to subtract 10. I'm going to do it from both sides. So that step was actually the same. Focus. Okay. So, what do we have left? Well, that canceled. The 2z was being subtracted. So it means I was taking that away. So it's essentially negative. 8 minus 10 is negative 2. Now look at how it's different than the previous one. We ended up with a positive 2z up here. Why? Because that plus sign belongs with the 2z. Here, the minus sign indicates what is happening to the 2z, so that sticks to it. And then how do we get rid of multiplication by a negative 2? We're going to divide by a negative 2. Now again, what you want to make sure, how do you make sure you're dividing by the right number? You want to get a 1z down here, which is effectively just z. Okay? Negative 2 divided by negative 2? Yes, that's a 1. But I got to make sure I do the same thing on both sides. Negative 2 divided by negative 2 is 1. So we did get different answers. But hopefully, I made myself clear here. You get rid of the constant first. So you're going to do that using addition or subtraction. And then you get rid of the coefficient next. And you do that with multiplication or division. Okay, plus or minus. And then here we're going to say times or division.